Good morning. Looking forward to this opportunity of sharing with you a geological excursion of Hervey Bay. I'm going up there next week to be part of a youth camp there, and the people who organised that wanted me to do a geological excursion. So here we go. This is what it's going to be all about, and I'm going to share my screen first of all, and we'll have a look at Hervey Bay, the geological excursion at Hervey Bay. This is a beautiful picture which the organizer of the camp took and sent down a swimming beach just very near the camp called Camp Pyalba. So we'll have a look at what it looks like. This is the camp, and right there, you can see this is just a Google map of Hervey Bay. The Hervey Bay is this little section which faces north. It runs along the Esplanade. It goes from Urangan in the east through Torquay, Scarness, and to Pyalba, and it ends basically at Point Vernon here on the west. And the Camp Pyalba is here at Pyalba. And the organizer of the camp took some photographs of the geology so that I would know what we're looking at. And this is the map that he sent. Camp Pyalba is just off the map. And the first photograph he took was at location A, which is a beautiful beach, a swimming beach within walking distance of Camp Pyalba. Then at location B, just towards, as we're approaching Point Vernon, and then getting up towards the point at location C. So let's have a look at some of the photographs. There's location C, and if I was showing this in the camp, a virtual geological excursion, I would ask the young people, what do you see there? And what I see is a sandstone platform, a wave platform running along here. It's fairly flat, it's fairly extensive, and it's composed of sandstone strata, one sandstone bed, and it's a hard rock because it's about 8 inches to 12 inches in thickness, and it's been like the bottom underneath has been exposed or excavated so that it's overhanging there. We can see the strata have broken off. There's a few pieces which are broken around, lying around. And in the distance, we can see that there are more strata in the background, and these have been eroded away so that they're no longer extending over this wave platform here. And in the foreground, we can see that there's some beach sand, which has been deposited here. And it's fairly freshly deposited. There are no footprints in it, but if we walked on it, we would see that indeed you could make footprints, you could dig it, you could make sandcastles in it. So there's basically two geological formations here, the sandstone strata and the beach sand. Let's have a look at another picture, looking at the sandstone strata from above, and we can see that there are joints or cracks that run through it. They run fairly straight, and there's two families of cracks that almost at right angles to each other. And so the sandstone, which is cemented very hard, is cracked, and we can see the beach sand in the distance there, and we can see from this relationship, this field relationship, we can work out which came first and which came next, what's first and what's second. And so in fact, the hard sandstone strata, the rocks, were the first to be formed, and then the beach sand was the second to be formed, the next one, the latest one. So if we have another look at another picture of the sandstone strata at location C, we can see something of how much has been eroded away. We can also see evidence here of some joints which are exposed just slightly, and we can see that there's been some weathering. Here's some what's called honeycomb weathering, where the holes have been formed as a result of maybe salty water. This is the idea, salty seawater getting into the sandstone, swelling and cracking it to form these little holes. We can also see something of the details of the sandstone itself. It goes from a pale color to a tan color, and probably most likely related to some iron minerals, some iron staining in there, and the iron may have some relationship with what the cement, be part of the cement that holds this sand deposit together. So that's a location C. We'll go to the next location, to location B, which is just a little bit towards the south and towards the east. And we can see that there are strata which are exposed. Again, we can see that they extend long distances, fairly straight. And it's the edges of the strata which are exposed because they've been eroded away. They've been cut off. And we can also see that the strata are on an angle. They're headed down towards the northeast. And geologists would measure the angle of that. That's called the dip. And from the angles that they measure, they can work out something of the structure of it, the geometric structure of these layers, and what could be happening beneath the surface which can't be observed. And we see the layers are the strata are fairly even in their width, and there's not evidence of erosion between the strata. So then we'll just when we've looked at this in the pictures, we see there's quite a number of different events which have occurred in the past. We see that the sand strata were cracked. We see that the beach sand was deposited. The sand strata have been folded. The sand strata were deposited initially. The sand strata have been weathered. They have been eroded, and the sand strata have been cemented. So there's all these various features that we've observed in the photographs, and if we were in the field, we would observe in the field and be able to get hands-on and just to get an idea for how good the cement process was, etc. So what geologists do then is that we need to organize this into a chronological order, and we can do that quite easily. And so the first thing is the sandstone strata were deposited. Then the sandstone strata was cemented. The sandstone strata were then folded, and then they were cracked. They were then eroded, and then the strata were then weathered. And then after that, the beach sand was deposited. So that we have is our order of the various geological events which we've been able to work out, been able to come to a logical conclusion by observing the rocks in the field. Next, I want to have a look at the geology transformation tool so that we can understand these rocks within a biblical perspective. Now, it does look a little bit complicated, but it's not really that difficult. And you don't need to understand or know and memorize all the different features of it. But basically, on the left-hand side, there is a table. Here's the table. And this has got lots of little boxes, long boxes, oblong boxes, different colored boxes in that table, and they're given names. And these are the names which are used by geologists where they classify the rocks they observe in the field. For example, here's a pink box called Cambrian. And so rocks which geologists think are Cambrian in age, which are Cambrian in features, they will then assign to a Cambrian box. Here we've got, there's Archean. That's another box. Here's another box joining those three together. It's called Precambrian. Then over here we've got, can you see that? The Jurassic. People are familiar with Jurassic and dinosaurs, and Cretaceous. So there's these various boxes of different colors. And when we encounter a geological term, we simply come to this box, this list of boxes, and we find the term that we've observed and figure out where things fit. For example, if we see a box that's called Triassic, we have a look around and we eventually find this little blue box here, Triassic, and we can see what boxes come after it, what come before it, and the next thing along here is a table of ages. Now, when we looked at the geology in the field, those photographs, we could see which ones came first, which ones came next, which ones came after that, but there were no labels attached to those rocks which gave an age of 100 million years. There were no ages attached to it. And these are the ages. There's a whole list of numbers here, and I put them here so that you can find your way around. And these are the numbers which geologists have attached to the various boxes based upon their philosophy, which is a philosophy that assumes that there was never a global catastrophe, as the Bible describes, never a global flood, and that everything happened slowly and gradually. And so that's how we find our way around. And next to that is we've got how you can connect the uniformitarian boxes and ages into the biblical history. Now, the arrows indicate the different parts of biblical history. The first arrow is a green arrow, and this is the waters of Noah's flood rising. Noah's flood rising, waters rising. Then there's the blue arrow, which is the waters falling, and then there's a yellow arrow, which means is post-flood, after the flood ended. The flood, of course, lasted approximately 12 months. The waters were rising for about 5 months. They were falling for about 7 months, and it's been about 4,300 years, 4,500 years, approximately since the flood ended. Now, notice that these arrows overlap a bit, and that's because there's not a one-to-one correspondence between the uniformitarian boxes and the biblical history. And that's because those who work according to the uniformitarian model philosophy, they use criteria to do their classification which don't exactly match the biblical criteria which would be necessary there. And they don't exactly match the processes, and it's got also to do with the location on the continents, whether near the edge or towards the center. And so there's not a one-to-one correspondence, which means we have to be a little bit careful. So that's our geological transformation tool. Next, what we do is we then need to dig out information about the rocks that we're interested in to see what other geologists have done. And I found this a very excellent little PDF, about 6 pages long, The Rocks and Landscapes of Maryborough and Hervey Bay. You can see that it's by Warwick Wilmot, who's written a lot of resources and booklets about rocks and landscapes of different locations in Queensland, including Brisbane, the Sunshine Coast, Carnarvon Gorge, Cairns, etc. And it's a well-written little booklet. It's written in a lay language, although slightly technical, and it enables us to understand what mainstream geologists are thinking and what they have observed. So that's the rocks and landscapes of the Maryborough and Hervey Bay, and it begins with first the big picture. You see that there? The big picture. And so I'll just put this up on the screen just so we can see it. And first the big picture, and we'll look at this little part here, just the first sentence. And it says the rocks around Maryborough were deposited in a sinking depression known as the Maryborough Basin, which extended eastward from Childers and Tiaro to well offshore of Fraser Island. This was about 140 to 100 million years ago, in the late Jurassic to the early Cretaceous periods. And there's a little bit more description of some of the rocks and some of the events that occurred. Now, of course, we can observe the size of these basins, and they've said it goes from Childers and Tiaro to well offshore. That's observations, and geologists have done those observations, but the dates are a philosophy. And so that's what we're aiming to do, is convert this information, this scenario, this narrative, to within a biblical scenario. So that's the big picture. And so here we come with our geological transformation tool. And it says that the Maryborough Basin was deposited from 140 to 100 million years ago, which is in this area here. And the booklet says from the late Jurassic to the early Cretaceous. So on this chart, the Jurassic ends at 145 million years ago. So the 140 doesn't actually fit into the late Jurassic between that PDF and this chart. And that's because the geologists keep changing the dates. And so there's an international conference, a commission on stratigraphy, and they regularly update their charts and change their dates. So the ones on here would be the most recent, and the booklet by Warwick Wilmot would have an older version, but it probably still is late Jurassic because it's based on other features apart from radioactive dating, more likely to be based on fossil evidence. But it's good enough for our purposes. It's just to indicate that there's a little bit of rubbery stuff in geological classification. So that's the Maryborough Basin, sits there. And we notice, first of all, that it's right towards the top of the floodwaters rising. So the flood has been going along for some nearly 5 months. The floodwaters are reaching their peak, and we read there how the fountains of the great deep burst open, and the windows of heaven, and the water prevailed on the earth, and it continued to prevail and continued to rise until every high mountain under the entire heavens was covered. And so here we are getting towards every high mountain under the entire heavens being covered. So then after that, of course, the floodwaters started to recede. We read in Genesis that the ark came to rest on the mountains of Ararat, and then the waters were receding, and they receded for something like 2.5 months before the other mountains in the area became visible above the water. And then after that, Noah let out a raven to try to find out if the water had gone, let out a dove, and a dove again a week later, and another week later, the dove. And so there's a whole sequence which is described in the Bible of what happened. So for the waters to start to go down, there had to be a change in the sort of geological makeup of the Earth's crust, such that the ocean basin started to sink and the continents started to rise. And we read in the text of this brochure, we can see how they're talking about parts of the geology forming blocks, which then were moving, and this is to do with the opening up of the ocean basins. So, and on this brochure, there's a very excellent geological map on the back. You can see that. It's not really in enough detail to be able to get any information from it, but you can see this is part here. See this is this is Hervey Bay. This is Point Vernon here. So it's just a little part of the map, and the map covers a large area, goes all the way out here to Maryborough, and the different colors mean different things. The green actually is the Maryborough Basin, and the geologists have identified 3 different features. There's a volcanic feature, there's the Maryborough Formation, and then there's the Barham Coal Formation. Here's the Maryborough Formation again, and then the Barham Coal Formation. We see that across the map. So we will have a look at a closer view, and here again we've got Point Vernon, Pyalba, Urangan. And I just like to point out on this part here, you can see this is called a syncline. A syncline. There's a line along here. And so a syncline is like when you get a piece of paper and you fold it up like this, and it forms like a gutter. And the line of the syncline runs along the bottom, and each arm of the syncline goes upwards. So the syncline is where the layers, where the strata come to and fold down to a bottom. And so from the syncline, they go upwards. And we can see as we go across here, we get to an anticline, which is this part here. And they give them names. Geologists have names things. And so this is an anticline. And so the arms of the strata They go downwards from the peak of this anticline, this arch. And so what this indicates is that the strata of the Maryborough Formation, they form a syncline, which goes down, the anticline, which is up, and there's another syncline just further to the west. And so they have formed a folding arrangement, an undulating, more than an undulating sort of an arrangement. And we can see on this map here, we've got the yellow indicating sand. There's a lot of sand deposits here. And then there's various other deposits which are in the area, including some volcanic rocks. So now what that's all explained in that PDF, which is the rocks and landscapes of Maryborough and Hervey Bay. And some of the formations which are described there, which I have extracted, are the Maryborough Formation, which is 140 to 100 million years ago, the Elliott Formation, which is 23 million years ago, accumulation of sand, it's mentioned 400,000 years ago, which is much less than a million years, and then another major deposits some 7,000 years ago, which is very recent. And so one of the interesting things about this is the Maryborough Basin is estimated to be some 6.5 kilometers thick. Now, this wasn't measured by drilling into the rocks, but it was measured by tracing across the rock, the surface of the rocks where they're exposed at the surface, and being able to measure across the surface to see just how far it was that they've been deposited. 6.5 kilometers. Now, Grand Canyon is not even 2 kilometers deep, not even 2. So 6.5 kilometers, 3 times, nearly 4 times the thickness of Grand Canyon. What's exposed there is deposited in the Maryborough Basin. The Elliott Formation be less than 100 meters. Less than 100 meters, much less, quite a thin layer on the surface. Then there's the sand and the later sand deposits. So let's now put them on our chart to find out where they fit within biblical history. Here we've got the Maryborough Basin deposited as the floodwaters were rising. And so this is part of that enormous catastrophe. The waters reach their peak and they start then to recede off the earth. And the Elliott Formation at 23 million years deposited here as the waters were receding, and then the sand deposits were post-flood. So there we've been able to interpret what we've seen near our camp at Pyalba within a biblical perspective. And that enables us to match the Bible with the real world. And when we look at, say, some of the geological features in Australia, particularly Eastern Australia, we see this little yellow feature here, which is the Maryborough Basin near Maryborough towards the top of Fraser Island, which is pointing out into the ocean. So that's the Maryborough Basin, late Jurassic, early Cretaceous, and is connected with the rocks of the Great Artesian Basin, also yellow, which cover a large portion of Eastern Australia. And these were all deposited as the floodwaters were reaching their peak. One of the last major deposits to be put in place as the floodwaters are rising. And of course, there's a lot of amazing features which are found in the Great Artesian Basin, further to the west of the coast. For example, we find enormous deposits of coal. We find dinosaur fossils. We find dinosaur footprints, numbers of areas where dinosaur footprints are present and preserved and have been, people visit them. And dinosaur footprints indicate that the dinosaurs were still alive. And so the waters were still rising, because when the waters reached their peak, the Bible tells us that everything that had the breath of life in its nostrils perished. One of the saddest parts that's in the Bible. So there we go. We've understood just where things fit together. And we'll end on this photo of the swimming beach at Pyalba, which is a beautiful beach, and the creek, the river, is entering the ocean at this point. So I hope that's been useful to you. I hope it's been very helpful to you, and being able to place yourself within a biblical model and be encouraging for you. So we'll end our little correspondence now.